Okay, here are your balancing equation notes. Let's see. Here are the steps. Let me hide this for you. Here are the steps. I would definitely suggest jotting those down just in case you need to look back at them whenever you take this quiz. So the first step is to write the unbalanced equation. A lot of time it'll be given to you. We're going to count atoms on each side. That'll make more sense when I show it to you. I have several examples that I'm going to show you. Add coefficients to make numbers equal. Remember, the coefficient is the large number in front, okay? Reduce coefficients to the lowest possible ratio. You will not always have to do that. I'll show you when that would be necessary. And then just double check and make sure everything's balanced on both sides. Remember, the law of conservation of mass says that they have to be the same on each side. I absolutely would write down these helpful tips because I use these all the time. And when I'm showing you your examples, I will show you how I use these all the time. So it is definitely a good idea to jot down these helpful tips. I will go over them in more detail in my examples. I will point out each one and show you. Okay. So I'm not actually going to do this example. I will click through it and talk to you about it, and then I will also do some myself in a second. But first step, write the balanced equation. If they give you a sentence like this, you're going to have to write it first, which is what we just did. So you should be good with that. So basically, we take aluminum, there's our Al, and plus copper 2 chloride, react to form, there's our arrow, copper and aluminum chloride. So you would write the equation first. Okay, there's actually going to be two ways of doing this. I will show you the way that that they have here. I don't do it this way, but you are certainly welcome to do it this way. Some people are visual and they like to see these atoms listed down here. See, they've listed Al, they listed copper, and they listed chlorine, okay? The numbers on this side are going to represent this side of the equation, and the numbers on this side are going to represent this side. I don't list mine. I just start balancing, and I will absolutely show you both ways, but we'll do this way first, okay? So the first step is to just list what you're starting with, okay? So see, I have 1 aluminum. How I know I have 1 aluminum is that there's an understood 1 in front, coefficient, times the subscript, which is also 1. 1 times 1 is 1, okay? I have 1 copper. That's because, update that. That's because there's 1 here, 1 here. 1 times 1 is 1, okay? I also have 1 copper here. Now, I have 2 chlorines because there's an understood 1 here. 1 times 2 is 2. So I have 2 chlorines, all right? On this side, I have 3 chlorines. Understood 1 here, 1 times 3 is 3. All right, the idea is to get them balanced, right? Our aluminum and copper are already balanced. Our chlorine is not. All right, so what you do is you put a number here to make these two equal. So the lowest denominator between the 2 and a 3 is a 6. So I'm going to try to get them both to equal 6. All right, so what you would do is put a 3 here, and look what that does. Look at everything that it changes. When I put a 3 here, it makes copper 3, because now 3 times 1 is 3. Okay, and it makes chlorine 6. 3 times 2 is 6. Okay, you should update those changes. If you put a 3 there, you need to update your atom count over here. Okay, now I'm trying to make this 6, the way I would make this one 6 is by putting a 2 right there, because 2 times 3 is 6, and that makes these two equal. And then 2 times 1 is 2 for the aluminum. See, 2 times 1 is 2, but it fixed our chlorines. Okay, so chlorines are equal. Make sure you update your atoms when you add a coefficient. And then you can go back and fix the copper and aluminum that you messed up pretty easily, okay? So we put a 2 there, and look, that equals these. So there's a 2 over here, now there's a 2 there, okay? And then 3, right? Put a 3 right here, and it makes that 3. It doesn't affect anything else, and now everything's equal, okay? I've got 2 aluminums, 3 copper, 3 copper, 6 chlorines, and 6 chlorines, okay? All right, so that's one way to do it. I am also going to show you some more examples, and I'm going to talk about some of those helpful tips I was showing you. All right. So this is what I'm going to do. I'm actually going to start down here. And this time I'm not going to list out all the atoms. I'm just going to balance it the way I do, okay? But you are certainly welcome to list them out. Now, one of the helpful tips is if you have polyatomic ions, count them as one thing. So look, here's sulfate, SO4. I'm just going to circle it. That's what I like to do. And I think it helps to tell people to circle them. SO4, and here's an SO4 over here. Sorry, I'm just going to undo that because I wrote on that too and it's confusing. Okay, here's SO2, SO4 over here. Treat those like one thing, okay? And so instead of saying I have one S and four O's, it just makes it more complicated to balance. Instead, you can say I have 3 sulfates and then I have 1 sulfate here. So you guys who like to list, like on that last example, like if you're going to list all of your elements out here, aluminum, bromine, K, then you also would need to list SO4 as one thing if you're one of those people that is going to like to list these out like this, okay? List that as one thing, all right? So let me show you how I'm going to go about this. I'm just going to start at the beginning of the equation, okay? I've got 1 Al here. I've got 2 over here, all right? So I'm just going to fix it. Okay, I need 2 Als. I'm just going to put 2 here. Now my Als are equal, right? So let's move to the next thing. Now I have 6 bromines, right? 6, 2 times 3 is 6 for bromine. So I'm going to put a 6 here because there's only 1 here. So 1 times 6 is 6. So now my bromines are equal. I fixed aluminum, 2 and 2. I fixed bromine, 6 and 6. That made me have 6 potassiums, and over here I only have 2. So that means I'm going to need to put a 3 there so that I can have 6 potassiums here. 2 times 3 is 6. Now, my sulfate is one thing. So you treat it like there's an understood 1 out here, just like with everything else. So 3 times 1 means I have 3 sulfates. And then right here, see, I also have 3 sulfates because there's nothing right here. When they give you these lines like this, you can leave this blank if it's 1, okay? You do not have to write a 1 right there. It's actually not even really correct to do that. So you can leave it blank if it's 1. And everything's balanced, okay? So on this one, here's the kicker though, and I forgot to mention this, so I'm going to mention it now. In order for you to leave these polyatomic ions together like this, they have to appear on both sides. So see how I have a sulfate over here and a sulfate over here? This is a good example, and this is why I did this one first. See, I have this polyatomic ion here, hydroxide, and based on what I just told you, you would want to keep it together, but it's not together on the other side. See, there's no OH over here. So you can't treat it like one thing if it's not together on both sides. You're going to have to break it up into oxygens and hydrogens, okay? One of the other helpful tips was that if an element appears more than once on one side, like here, look, I've got hydrogen here and hydrogen here, then balance it last, okay? Save it till the end. Okay, so as I start, look, my leads are actually equal. They're 1 and 1, so that's not where I'm going to start. But the most obvious thing I see, because I'm trying not to mess with my O's and H's till the very last, is chlorine is 2 over here and 1 over here. So I'm going to start here. I know I have to fix that chlorine. So that fixes my chlorine. So let me see what else it messed up, though. Here I have 2 H's and 2 O's, right? And here I have 2 H's. So total on this side, I have 4 H's, okay? On this side, I only have 2 H's, right? So if I put a 2 right here, now I got 4 H's on both sides. I've got 4 here. I've got 2 here plus the 2 right here because this 2 distributes in is 4 total, okay? So my H's are equal. My chlorines are equal. My H's are equal. Let's look at our oxygen. Look what that did for oxygen. The 2 distributes in, so that means oxygen has 2. Okay, and some people like to just write it in there, so it keeps them like a 2 and a 2, just so that it keeps them straight. It's just kind of like notes for yourself. Okay, so I have 2 oxygens here and then 2 over here, so that balances that one. Okay, so it is helpful to save them if they appear more than once on one side. Save them till last, and sometimes they just work themselves out like that did. Okay. The last thing I need to show you is sometimes when you're balancing it, you kind of get stuck. So let me take you through that process. We have 2 carbons here and only 1 carbon here. So I'm going to put a 2 in front. That makes me have 2 carbons and 2 carbons. All right, I have 6 hydrogens here and only 2 here. So if I put a 3 here, right, I have 6 and 6 here. Equal. Everybody's equal. Everything's going good, right? When I get to my oxygen, look what happened. I've got 4 oxygen here and only 3 over here. 4, 5, 6, 7, right? That's 7 total oxygens on this side. Look, nothing times 2 equals 7, right? So it's kind of like you hit like a road bump. When that happens, what I tell people is take the one you were basing everything off. Like I made all these changes over here. I put this 2 here and this 3 here, all because of this formula right here. I was basing everything off of this one right here. So if I'm working with a 1 and I know that's not going to work, this nothing times 2 equals 7, go up by 1. So if it's a 1, double it, go up by 1 to 2, and then start over, okay? So just real quick, if I'm going to go up, that means I would need to erase this, and then just kind of start over. So now I have 4 carbons, so I'm going to put a 4 here to make them equal. I have 12 hydrogens, so a 6 would go here because 2 times 6 is 12. All right, now they're equal again. Now this time when I add up my oxygens, I've got 8 here plus 6. So 8, 9, 10, 11, 12, 13, 14 total over here. And guess what? 2 times 7 equals 14. So sometimes if you just take your coefficient and go up by 1, you can fix some of these that you get stuck on, okay? So like I said, if you like listing them out like this, or if you like just going through the process I did, you can do any way that you want to do whatever you feel comfortable with.